All right, so we're going to talk about the distance formula. And so I thought the best way to do this would be to explain why this works. So let's say I've got the points 2, 4, and negative 4, 6. 2, 4, negative 4, negative 6. So I want to know the distance between these 2 points. So how would I figure that out? So to figure this out, what you'll notice is that if I were to drop a line maybe down this way, and then another line this way. So here's the deal. I can figure out what this distance is, and I can figure out what this distance is. And that's really the change between the x values and the y values. And in creating this little sketch here, now what do I have? I have a right triangle, right? And so, okay, let's find these sides. So this side here, so this goes from negative 6, so we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this side is going up 10. And this distance here, so let's see, I'm going from 2 to negative 4. So I go 1, 2, 3, 4, 5, 6. So this is a distance of 6. So I know these two distances, and since this makes a right triangle, I really just need to figure out what the hypotenuse is, right? And we can use the good old Pythagorean Theorem for that. So I can just take 6 squared plus 10 squared equals that distance. And so that's 36 plus 100 equals the distance, squared, the distance squared, my bad. And so the distance squared would be equal to 136. So that distance would be equal to 136. And 136, so the square root of 136, we'd have to throw it into a calculator. The distance would be approximately 11.66 units. But square root of 136 is a little bit more exact, actually. So the distance formula is really just an application of the Pythagorean Theorem when you take the time to illustrate it. So here is the distance formula in all its glory. I always like to talk about why it is what it is, because I always like to say that I have the memory of a hamster. And so I cannot remember formulas for the life of me unless I have to use them all the time. And the distance formula is one of those formulas where it just kind of pops up every now and then. So good luck remembering it. If I just showed you this, it would just look like this dumb, useless formula, right? But if we talk about where it comes from and that it's just an application of the Pythagorean Theorem, personally, I can remember the Pythagorean Theorem and I can solve it that way, so I think it's helpful to know that they're kind of one and the same. So this part right here, this is talking about those distances between the y's, and this is talking about the distances between the x's. So in what we were counting out, these distances here, this part here would have been taking the y2 minus the y1, and this distance here would have been taking the x2 minus the x1. So that's literally what we did. We just did what the distance formula was doing. So you can use the formula, or you can always kind of draw a little picture to go with it, or both, or whatever. So anyways, I want to now do an example where you find the distance between these 2 points. So I think you should pause the video here and you should just give this a try before you watch me do it. Okay, so the distance, so it doesn't matter, by the way, which one you want to call x1, y1, x2, y2. So I'm just going to set this as 3 minus negative 1 squared plus 7 minus 4 squared. So let's see, that's going to give me 4 squared plus 3 squared. So that's going to be 16 plus 9. So that's the square root of 25, and so that equals 5. Cool. So that would be the distance between those 2 points. So the distance formula, I think, is pretty straightforward. There are a few ways to use the formula, though, that maybe are not as straightforward, or you've got to think about it a little bit. So the first way I want to talk about is determining vertices of a right triangle by using the distance formula. So let's say in this case now I've got 3 points. So what I have to do here is first I have to find the distance between each pair of points. So let's do that. Let's find the distance between 0, negative 2, and negative 4, 3. So that distance is going to be 3, we'll call that 3 plus 2 because it's minus negative 2. And then negative 4 minus 0 squared. And let's see, I'll give myself just a little bit more room. I gotta save some screen space here. So this will be 25, square root of 25 plus 16. And so that equals the square root of 41. So the distance between these 2 points, this distance is going to be the square root of 41. So let's just table that for now. So up next, let's do 0, negative 2, and 5, 1. So I'll just write that here, 0, negative 2, 5, 1. So let's find the distance. So let's see. I'm going to have, how about negative 2 minus 1 squared, 0 minus 5 squared. And I need to take the square root of that. So that's going to give me negative 3 squared plus negative 5 squared. So that will come out to 9 plus 25, which is the square root of 34. So we will call that the square root of 34. And now let me clear some space. And so the last set of points that I need to do, so I've done these two, I've done this one and this one, so now I need to do negative 4, 3, and 5, 1. So let me just mark that, negative 4, 3, 5, 1. So now I'm going to find the distance one more time. Actually, I'll go like this. 3 minus 1 squared plus negative 4 minus 5, I can't write today, squared. Okay, so let's see, that becomes 2 squared plus negative 9 squared. So that's going to give me 4 plus 81, so that equals the square root of 85. So this one is the square root of 85. Okay, so let me clear some space. All right, so step one of this is to find the distance between each possible pair of points. Then, like I said, you want to use, so like the idea here is we're trying to figure out if these make sides of a right triangle. And the thing about a right triangle, right, is that the right triangle has our old friend, the Pythagorean theorem. A squared plus b squared equals c squared. So if I have this relationship, then I know I've got a right triangle. So when I look at these 3 points, if I try to think of how could I plug them into this formula, so probably the best way to do that would be to take square root of 41 squared, it's a terrible 2, and then the square root of 34 squared. Does that equal the square root of 85 squared? And you my friends are saying, well, that comes out to 41 plus 34. Does that equal 85? And you're all saying, no, 75 does not equal 85. And so now that I've seen that, there's really like no other way I could try to fulfill this relationship, right? Like it wouldn't make sense to do like square root of 85 squared plus square root of 34 squared equals 40 square root of 41, right? So there's no like other way to arrange these into this formula. So I can see there's no way to make this equation work. Therefore, the conclusion is not a right triangle. All right, so I've got one more of these. I know that these are a little tedious, but I think seeing just 2 of them can be very helpful for your understanding. So what I recommend that you do here is that you find the distances between the different points. So take the time to figure that out and then hit play when you're ready. And I'll meet you there. Okay, so I don't want to spend a lot of time, like if I do this, it's just going to take forever. So let me just show you the work involved with this. So I'll start with -2, -8, and 0, -4. So here's the work for that. And then here are the next set of points. So let's take -2, -8, and -4, -7. Okay, so I'll make a little space. And now I'll find the distance between 0, -4, and -4, -7. So let me show you that. Okay, so now I have all my distances, so let me clear some space. And now we do that same little exercise, right, where I want to see if I can get this a squared plus b squared equals c squared relationship. So if I set that up, if I take 20 square root of 20 squared plus the square root of 5 squared, does that equal 5 squared? So then I get 20 plus 5 equals 25, so that relationship holds. So yes, so what we have in this case is this would be a right triangle. And so that's the way that you can use the distance formula to do that. Now, there's one other way that you can use the distance formula, and that's determining collinearity, which of course then the natural question is, what is collinearity? So 3 points or more are collinear if they lie on the same line. So they can be collinear, or collinearity is a related word, so it just means the idea that they all lie on the same line. So to show you how you can use the distance formula to do that, so we're actually going to do something very similar to what we did before. So going through each pair of points, we're going to go ahead and pair each one up and find the distances between them. And so just for the sake of keeping this video short, I'm going to go ahead and show you how I find those different distances once again, and I'll just kind of fast forward through the video because I know it's just kind of boring to watch that. So let's go ahead and do this. All right, so next I'll do -1, 4 and 1, 14. And again, I think you're going to get more out of this video if you also do this alongside of me. So if you just copy everything down, you're not going to remember it as well. So if you're watching this to learn the distance formula, I would recommend doing these on your own and then just check your answers against mine. So anyways, I'll keep going. Okay, and once again, I'll clear some space. And then we have -2, -1, 114, so I'll show you that. Okay, and so now I'll clear some space. And now we have to discuss, what do you do with these distances? And okay, so these are collinear. So visually, what you're thinking of is a line. You want to see if you can like prove this type of relationship via using distances. So what I want to do is I want to see if this distance here, let's call this distance 1, and this distance here, let's call this distance 2, if I add those up, do I get this whole distance here, which we'll call distance 3? So we're just going to use plain old addition. And so this is going to require just a little bit more finagling. And in this particular instance, what you're going to want to do with these square roots is you are going to want to manipulate them a little bit and simplify them a little bit. So let me clear just a little space here so I can explain this a little bit more. So like the square root of 26, I can't simplify that anymore, so just got to leave that one alone. But the square root of 104, this simplifies into 4 times 26, so this can be simplified as 2 times the square root of 26. And then for 234, so the square root of 234, this one can be simplified as 9 times 26, so this can be simplified as 3 times the square root of 26. And so that's going to matter for this particular problem. We actually, like the last set of problems, like we didn't need to simplify the square roots, but for this particular application, it's helpful to do that. So I'm just going to note these simplified forms up here, and then I'll clear some space. And now I think you can probably more clearly see what we need to do. I've got this square root, and this square root. So is there any combination that if I add 2 of them, I could get the third one? And now you can probably pretty clearly see, right? If I take the square root of 26 plus 2 times the square root of 26, I am going to get 3 times the square root of 26. And so, yes, this would prove, so yes, these are collinear. And so that's the idea. Okay, so I want to try this just one more time, one more example. I highly recommend that you try this one on your own. For this one, I am going to omit, I'm just going to blow right through the distance formula so you can just see all the different parts of it again. So let me go ahead and do that. Okay, so you can see that I've got the distances. So the first 2 points, the distance was square root of 241. Negative 2, 4, and negative 2, negative 4, and 0, negative 12. That distance came out to 68, so let me clear some space. And now I'll find the last set of distances. Okay, and so let me clear space. And now what I'd like to do is just take a moment to see if I can simplify any of these square roots. So square root of 68, I can't simplify any farther. What about the square root of 241? Can I simplify that? Not really. If you play around with it a little bit, you can't simplify the square root of 241. And then what about 565? Again, you can't really simplify it as anything meaningful. Now, what you could do if you're a little paranoid is you could always just try to get like a decimal approximation of each of these. So if I do that, I'll get the 3 approximations that you see here. So I've got 15.24, 8.25, and then 23.77. And so you can see that if I were to try to add this 15.24 and this 8.25, this is just shy of 23.77. So these 3 are actually not going to be collinear. They're not collinear. All right, and so that brings us to the end of this video. So I know the distance formula can be a little bit drier, but you know, it takes a little while to just get through some of those examples. But if you found this helpful, please consider just leaving a like or a comment for the video. And otherwise, I will catch you guys in another video.